All right. Hello, everyone. I know this is a weird backdrop to be starting the stream on, but it's because we had a pre-stream question that was about the C runtime library, so there's a little bit more busy. You know what? Here we go. I'll just get it back to normal. This is what you would normally see, right? There you go. Hello, everyone, and welcome to Handmade Hero. It's the show where we code a complete game live on Twitch. No engines, no libraries. I think, I was describing this to some folks on Twitter, and they seem to really like the description of the game, that it is a game about limbless children and demons, which is bound to be the feel-good hit of the summer, whichever summer we decide to release it in. I don't know why they particularly liked that description, but, who doesn't love limbless children and demons? I mean, that is good, wholesome family entertainment. Right there, I don't think anyone would ever disagree. Anyway, that said, we finished up some general purpose allocation stuff last week. It took a lot less time than I thought it was going to take, even to just do the rudimentary one. And doing an optimized one really has to wait until we put a lot more pressure on the asset system and can even see, where or if it falls down. So we were kind of like, all right, I guess that was it for the general purpose allocator. It just kind of happened, and that was it. So what I wanted to do is move on probably to the next thing on our list, really, and that is going to be debug code. I think it's the most logical thing to do. We're getting towards the point in our engine dev here where we want to start locking things down, cleaning them up, and just doing sort of a general thoroughness pass. We've got some bugs and things that we know we have to fix later. Things that are not at the level of quality that we want them to be, that we made note of. And so what we want to do is kind of move towards a place where we can be happy with the basic engine layer that we have put in place, so that we can move on to working on the game and being confident that all the services that we made will be reliable and we won't have to constantly be debugging them or fussing with them. And we'll only have to actually do new engine work driven by gameplay things that we want, rather than it being some kind of a maintenance headache for us, right? And so what I thought we'd do today is probably start down the road towards fonts, because in order to do much in the way of debug code, we kind of need to be able to display text on the screen, because we're going to want to print out, values and just, assorted things that we're gonna want displayed are going to require some kind of font work. So I thought that's what we do today. So I'll talk a little bit about fonts and on the blackboard, and then we'll do some code. Today is day 162, so if you'd like to follow along at home and you are someone who has pre-ordered the game on handmadehero.org, you want to unpack day 161's source code so that you will be at the same state I am, and that way you can follow along with the code exactly as I am opening it up as we speak. So I believe, like I said, I don't think we left anything dangling really, other than saying that we probably should optimize the general purpose allocator once we have some workloads. But that's a little bit further down the line. So I'm going to go ahead and just double check that everything was fine, but I'm pretty sure that it was. So yeah, if I go here, we're still all totally correct. Nothing bizarre happening. We don't have asset pre-caching in there yet, so we still have blinking when things first load, but that's about it. And the pre-caching is really just something that's more about us eventually deciding how those calls are going to get issued, because the asset system actually already supports it as well. So I think everything's pretty good there, and so I think what I'd like to do is start to figure out how we can do some better debug overlaying, right? Some stuff that we can put on the screen now to kind of give us a little bit more ability to have insight into what our code is doing. A lot of times people ask on the stream in the Q&A, they'll say stuff like, how do you feel about test-driven development? And just one of the things that's often true about game code is that the hard things to debug are often not really super possible to tackle with test-driven development. Test-driven development really only tackles the easy problems in game development, ones that really just don't super need to be worried about all that much, because they won't be accounting for the majority of your dev time in a lot of cases. And so what is actually more important in game development than test-driven development usually is like visualization-oriented development, however you might say that, which is to say that as your game kind of goes through more and more, goes up in levels of complexity, simply looking at the end results is oftentimes not sufficient to know whether things are really working or not. because there can be a lot of bugs lurking in the code that are very complicated and would be difficult to ever diagnose with a test or simply by inspection or simply by looking at the end results. And so what we tend to do a lot of times is we tend to write visualizations like HUDs, overlays, and stuff that try to show us a lot of heartbeat information to see what the game is actually doing so that we can use our intuition to detect when patterns look like they might be wrong so that we can investigate further and get some of those harder, more subtle bugs that are very difficult to find any other way. And so that is one of the main reasons we're going to need fonts. This game, I don't know that the game itself will be all that heavy in terms of printing text out, but I think for our visualization we will want it, and sooner rather than later. And so I'd like to talk a little bit about how fonts work in general, and then how we can implement fonts in our game. So here we go. Here's day 162, and we'll say fonts. But sometimes I like to call it fonts with a CE at the end. I don't know why. I feel like that's just kind of fun to say, fonts. It sounds the same, but it looks kind of interesting and cooler. So anyway, day 162 fonts. What are we talking about when we talk about fonts? What is incorporated in a font system, right? And I'll start from the very basics for people who don't know any typography or anything. And we'll kind of work our way up to, so that no matter where you are on the spectrum of knowing about fonts, we will bring you up to speed. Okay, so obviously we kind of all know, just no matter who you are, if you've ever worked on a computer, you have a passing familiarity that a font is something that kind of describes the way text looks on the screen, right? And you've probably seen, files, TTF files, which are like true type font files, right? Which are the ones that we see on Windows a lot, but there's also like Adobe Type 1. In fact, I don't know if you saw recently, Microsoft had a really bad hack involving Adobe Type 1 fonts where people could root your machine by including Adobe Type 1 fonts on the web, right? And there's been other types. There's Metafont is another kind, which was an old thing in LaTeX, right? There's a number of different types of fonts out there, font sort of file formats, right? And what these are is, these are ways of describing what the actual characters in fonts are supposed to look like, and they're usually described in terms of outlines. So typically, for example, like in a true type font file, for example, or Adobe Type 1 font file, typically what you're doing is you're doing something, if you've ever seen like Adobe Illustrator or something, you're typically doing something like that. So a typical font file might include something, like some vertices, to describe like the letter T, right? They might describe something that looked like this, right? Where you were kind of saying, okay, we have some coordinates of some vertices, and we have some curves, in this case, not really curves, but lines that go into the vertices. And the way that we're going to describe the shape of the T is to say that we're basically talking about a filled area that exists within these points, just like you would, again, in Adobe Illustrator. And similarly, if for a curve shape, right, then what you're going to have is you're going to have something where you have points, and those points are going to have like Bezier curve handles or something like this, which we've talked a little bit about. I also have a video online about interpolation for Bezier curves, which is not really something we need to go over at the moment. We'll probably go over it a little bit later in Handmade Hero. But point being, they're like those things you see in drawing packages where you specify, 2 points and then 2 points that are sort of off of those points, and you kind of get these little handles, right? And then it draws like a curve based on the points and the handles, and like as you move the handle around, the shape of the curve changes, right? You might get something that looked like that. But again, it's the exact same concept as the lines. It's just saying, here's a filled shape, and we're going to fill it in, okay? So that's the first part. That's the first part of what's happening in a font file, right? Is it's basically describing some filled shape that is, for all intents and purposes, resolution independent. Meaning there's not really a notion of pixels here necessarily. There is a little bit of a thing called hinting, which I'll briefly mention, but we don't really care about it so much. But for the most part, we're not really talking about pixels here. We're just talking about an abstract shape. and that abstract shape could be scaled as big or as little as you wanted, and it would still be able to be infinitely precise because, again, it's not talking about individual pixels, it's talking about just that shape. So just like in Adobe Illustrator versus Adobe Photoshop, in Adobe Illustrator you can make the shapes and you can scale them any size. In Photoshop you paint on the pixels, and then that's, if you resize it, it gets blurrier or hard, right? It's the same deal, right? So we're talking about continuous shapes, not pixels. And the reason behind that is because people want to be able to ship one font file that allows them to use that font at any scale, right? You want to be able to ship, Times New Roman and be able to say, I want it 20 points, 30 points, whatever, right? And it gets bigger or smaller, just like you do, in any package that you use. So that's the first thing that they do, is try to describe a relatively resolution independent outline shape for the font that would allow a program that wanted to fill it in to fill it in. Now, the second thing that these do is they describe a mapping from some character set encoding to these outline shapes, right? And what do I mean by character set encoding? Okay, what does that mean? What I mean by character set encoding is that in the English language, right, or in Chinese or something, right, we all know what we're talking about when we say like the letter T, right, or the symbol for meat or something, right? I think it's got like a little, it's like something that looks like this, right, or whatever. I don't know, I'm trying to give an example in Chinese, but I don't speak Chinese, so it's hard for me. But anyway, there are these glyphs, right? And so the font file can describe this glyph. It can describe T, it can describe the symbol for meat, right, or whatever. But how do you know what symbol it's describing, right? How do you know? We can't just give it, some arbitrary number, like, okay, this is, glyph 17 in the file. Well, how do I know when I wanted to actually show the symbol for meat? How do I know that was glyph 17, right? And so the answer that we've come up with in the computing world is to have these character set encodings. And one of them you're very familiar with if you've watched Handmade Hero from the very, very beginning. In fact, I think it was maybe in the intro to C part. I don't know. I don't even know if we did it in Handmade Hero. It might have been even in the test thing where I did a little bit of C stuff. But basically, there's ASCII /ANSI encoding for characters. There's basically a character set encoding that allows you to do most like Roman-derived languages in a standard way, where we've basically just defined what all the characters are, right? We basically said, okay, if you're writing Spanish or English or French or something, we have mapped, sort of in a definitive way that everyone has agreed to use, we have mapped all of the characters to some symbols. So we just know that O is 79. Right? Like that's just what we know. So inside the file, we could say something like, we are using an ASCII encoding. So when we tell you that this glyph corresponds, right, to, index 80 or something, we know that that's going to be, that's P, right? We know that that's P. So in the case I gave of T, we would know that we would put 84 as a numerical tag on this T. We'd say 84 is the T, right? And so the choice of character set encoding is very important because it defines what characters you even can encode. Now, for example, the symbol for meat in Chinese has no encoding in ASCII. You can't encode it. So if you were to pick a font description that only allowed you to use ASCII, you would not actually be able to include that character in your font. It just wouldn't happen because you'd have no way of even telling someone what it was. Now, what you could do instead is say, okay, you know what? I didn't really need this weird block shape that's like number 223 in extended ASCII. So I just said like, okay, that's going to be the meat symbol. And just in my game, I know to use that, right? You could do that. Another thing you could do is use a thing called code pages, which are like ways of switching out ASCII for a different set encoding that would only work in for like, say, Chinese or something. But again, you haven't really solved the problem. And with only 256 glyphs, which is all you're going to get out of ASCII anyway, you're not going to be able to do something like Chinese, which is going to have at least 3,000 symbols, even in a basic situation, and up to 30 to 40,000 symbols in the case of one that was supposed to encompass the entire, archival, ancient set where you were going back through all all the symbols that have ever been used in Chinese lettering. Right. So what we have done recently is we've moved to a thing called Unicode as the more standard thing, right? This is kind of the older school approach. This is like the newer school approach, right? And what Unicode is Unicode is a way of encoding drastically more characters. It goes up to 16 bits in the naive implementation, like with Windows, a thing called UTF-16. And then it goes in UTF-8, which is a different encoding of Unicode. It actually can go above 16 bits. It can actually do more. And so, like, as we know on Handmade Hero 65536, right, we know that 16 bits would give you 65,000 symbols. That's quite a few symbols. That's awesome. But UTF-8 allows even more because it's basically a variable length encoding where it's still 8-bit characters, just like ASCII is, but you can kind of double up the characters and say that, like, a particular character can say, oh, there's another character coming after me that combines with me to produce the actual value. And so you can kind of like chain them to be as long as you want at that point. So you can get up to 24-bit of address space, which is 16 million glyphs, right? So basically, Unicode is the way that we sort of broken through the ASCII table that was just 1 byte per character, that which was insufficient. So now what Unicode is, it kind of has a good and a bad to it, if you will. The good thing about Unicode is that every character has a unique identifier. Well, it's not quite what I mean to say, but all glyphs have sort of found their home in Unicode, right? So it doesn't matter what random language you want to do, even if it's one that like isn't even spoken anymore, right? Somebody somewhere, hopefully, has allocated some set of the Unicode mapping and said, here is where those symbols go, right? And what that means is a single font could literally, if it wanted to, describe all of the symbols that all humans have ever used to ever write anything down, like period, right? And that's pretty cool. But the problem with that is that you're stuck with that in giant encoding, right? So you can't just use a table that's 65K entries long or more, like 16 million entries long. That'd be a crazy huge table to use in your game of fonts, most of which would be 0 because your game isn't translated into Sanskrit, right? Your game isn't translated into all of these archival languages potentially, right? Your game just isn't going to use all those. You don't have the font for it anyway. You're never going to display them. So usually what ends up having to happen, and the thing that's a little bit nastier about Unicode, is typically you have to sort of treat Unicode as an intermediary mapping because your lookups cannot be dense anymore. So typically what ends up happening is you've got some kind of a translation process that you go through. So if you wanted to use Unicode, it's typically going through some kind of a mapping to finally get you into a dense table of what does my font actually have in it? And that would be dense, right? So I'd have a table of just, this font has 500 glyphs in it, right? And Unicode is this gigantic, 24-bit address space or something, right? It's not actually 24-bit, I don't think, but, somewhere up there, over 16 bits of address space. I go through a mapping that's some way of crunching this down to actually get it to figure out where in this dense table of actual font glyphs I'm actually trying to look for the font glyph that I want. So it's just something to be aware of. Like Unicode just kind of has this nasty property of, because it's supposed to be a universal encoding that can describe any glyph, it's actually not very good for describing the glyphs that you have. So typically what you end up doing if you want to support arbitrary languages in a system is, yes, you accept Unicode as your encoding, but then whenever you get one and you want to actually start working with it to display something on the screen, you go through some kind of mapping that will put you into the right place in your table of glyphs you actually have, right? Okay, so back to our font files. So what the font file ends up being at the end of the day is typically something like a Unicode. Oh, and by the way, I didn't actually say it. They are called, this sort of entries into the Unicode table, they are called code points. So when you hear someone say a Unicode code point, they are referring to that numerical slot that has been reserved for this glyph. Slot 63,452, all right, which corresponds to whatever glyph, that's like a Unicode code point. That's typically what that phrase is used to describe, right? Yeah. So anyway, so that's typically what ends up being in something like a font file, is it will be something like, here is an outline of a T, here is the Unicode code point, right, that describes which glyph I'm talking about. So now the code knows, oh, okay, that's an English letter T. Okay, I get it, right? Or that's the Chinese symbol for meat, right? I get it. So now it's basically like a way of bridging that gap of, I've just got a bunch of outlines in this file. I need some way of telling you, what do they actually mean to a human who spoke this language? What do they mean? And that's what it tells you, right? So the code point is almost all the information we need. Almost all, right? We've got a glyph, we've got the code point, but it's not quite enough yet to actually constitute a useful font. And the reason is because we don't actually know how to start assembling multiple characters together into words. So let me tell you a little bit about basic typography here. I'm not going to harp on it because Handmade Hero is not about text, so we don't have to be expert typographers to do the implementation of the font system in Handmade Hero, right? If you were doing a game that was all about fonts, you would want to be an expert typographer, certainly. But I'll give you a little bit of the basics. So in typography, right, there's basically everything is about sort of the solids and the empty spaces and the solids of the fonts, the shapes they make and how they like interrelate. They spend a tremendous amount of time thinking all of this through. And they have a bunch of properties about fonts that they think about. So for example, you might take the letter G, and if you wanted to talk about that shape, there's a number of things that you could talk about. You could talk about the fact that, for example, the G, unlike the H in a standard font, you might say that the G has a descender in typography speak, which is this bit that comes below sort of the line here. And then you might say that the H had like an ascender, which is something that kind of comes up above this, right? There's ways that they describe these things. But this line right here is often referred to as a baseline, right? And so one of the things that is described oftentimes in a font file is what is that baseline and what are the characters how does the character glyph relate to that, right? How does the character glyph get positioned relative to the baseline might be a piece of information that's necessary in the font file, right? Similarly, something like what is the maximum descender height, right? Like of all of the characters in this font, what's the one that goes down the furthest? Of all of the ascenders, what's the one that goes up the highest? And again, these are things to allow you to know when you're going to go use this font, what is its general span vertically, and what is the actual region that it actually typically uses, right? What is, another one would be, what's the line height? Meaning, what did the fontographer who created this font envision being the spacing between lines in a normal scenario? Like, you know, if I was going to put the next character down here, where would it be, right? So you start to have some information like that. But most important of all, and unfortunately a lot of fonts just don't even do this very well, but ideally speaking, your font file has a thing called kerning. Kerning information. And what kerning is kerning is a way of understanding how to adjust the positioning of letters horizontally based on which pair of letters you're talking about. Okay? And so to understand the difference between these things, you first have to sort of think of the difference between mono and proportional, right, fonts, which you've probably seen before, right? A mono or monospaced might be the more appropriate term, right? Monospaced font. A monospaced font is the old school kind that was on typewriters and terminals when they did not have the level of sophistication necessary to advance the right position by a variable number of pixels or space on the typed page or whatever, right? And so what happened was a font just had to have an equal amount of space. So if I had a G and I had an I, they both had to take up the exact same amount of space width-wise, which looks pretty dumb. because there's this giant gap on either side of the I, right? Because if you were to make it the size that you would normally want to make the I, the G would like sort of overflow it, right? So you kind of had to adjust it to make it some kind of uncomfortable size that was too big for some letters and too small for others, but you know, it kind of was like the best you could do, right? And so as you typed away, it would just move by that amount, and you would end up with something like the word gill would look something like that, right? Where the spacing was consistent between each of the center points. And it would look really stupid because the way that fontographers who laid it out in lead would have done it would be like that, which looks a lot more natural and is easier to use, and also helps articulate the difference between spaces in between letters, which are not what you want to focus on when you're reading, and spaces in between words, which you do, because it helps you tell, right? Words are recognized kind of as a chunk, and so you want them to group together cleanly and not have the person be confused about what is the space and what is the word, right? That's not a good thing from a typography standpoint. Okay. So once we had the sophistication to do so, proportional fonts were definitely a preferred thing to do because they were certainly better than monospace fonts for readability, and so systems wanted to support that so they could produce better looking output that was more on par with what typographers were able to do, because they had refined that in sort of the printing press style, right? They were making characters that were different sizes already. And so what we wanted to do is we wanted to, in computing, we want to be able to do that same sort of stuff. And so what we can do is we can say, okay, now whenever we draw a glyph, when we draw the next glyph, we'll just sort of have some understanding of how far to go. But if you think about it, it's actually a pretty tricky problem because the actual distance you might want to go is not necessarily constant depending on the letter, right? A naive proportional font implementation just says, okay, for every letter, there's a certain distance I will advance, right? And that's fine in general, and it solves our gill problem to some degree, right? But what it doesn't solve, and what's sort of a level above that, right, is the concept that depending on which two letters you were putting back to back, you might choose a different amount of space. And to give you sort of an example of how that works, right? Suppose I was to take the letter G and the letter J, right? And I was going to put those two characters next to each other. Well, I would probably want to space them so that there's like a reasonable amount of space here, which would leave kind of more space there, right? So when I'm thinking about how close this J should be to something, I have to consider that, right? It's going to be a little bit different there. Now, on the other hand, if I had an I, right, and a J, those could go much closer together because the J descender can easily overlap the I, right? The same thing would be true in the forward direction. That was kind of a backwards-looking kerning example. The same would be true in a different example. If I have an F, right, and I'm going to follow it by an H, right? I guess I drew my F kind of poorly. If I have an F like that, right, and I'm going to follow it by an H that goes all the way up, right, like so, I would probably have to space these so that, it looks something like that, which leaves a fair bit of space here, but, it's because of the closeness there, right? Again, on the other hand, if it was an I could probably snuggle that I in right next to it. In fact, this is so common, there's even a thing called a ligature, which we don't really have to cover in Handmade Hero, but there's a thing called a ligature, which is actually when the fontographer creates a unified glyph designed to represent F and I together because it's so common, and oftentimes they'll do it. It looks like that. It's like a combination of an F and an I, right? So yeah, but point being, the distance between letters can be highly dependent on the pair of letters, not just the letter that came first and advancing by a certain fixed amount. And so that's where kerning comes in, which is the idea of modifying the inter-character spacing to account for that pairwise difference. And so what you end up having is you have another lookup table in this font file, or I shouldn't say a lookup table because it's just information encoding in the font file, right? Which would be something like, a simple example would be something like this. It would say, a character A, character B, or I should use something else, character 1 and character 2. I don't know what to say. Character, I can't use anything because any glyph is going to be something that could be in there. Character A and character B, and then a kerning value. So it would say like, okay, if there's a G and a J that are back to back, I want you to do, the spacing is 5. If it's instead an I and a J are back to back, I want the spacing to be less. It's going to be a 1, whatever. And oftentimes the way that kerning is represented for encoding reasons is that typically it's actually not the total amount of spacing. That's really not what they tend to encode. Kerning typically refers to the delta between the normal spacing and this pair spacing. So typically what will happen is you'll say, okay, there's a normal spacing. There's a normal advancement, right, for a G. So in the table where the fonts are encoded, we say G advances 10 units, right? That's what G advances. And the kerning for GJ would say, okay, you were going to advance 10, now subtract like 5 from it. So you actually just do 5. So instead of encoding the 5, it encodes a negative 5, which is the delta from the G's spacing to the, you know, right? That's just how that goes, right? The idea behind that, I believe, is to save space, right? Because if I just encode one, remember this is an n squared thing, right? This is n squared because if I was to encode the kerning for every single font pair, I would basically have, you know, a times, like however many there are, like if there's n glyphs, I would have n times n entries in this table. And so I think what they do is they like, the reason they don't just describe the spacing entirely by an n times n table is because I think they were trying to say, well, it'd be more efficient to say, let's just describe a default spacing that goes after every character, and then we'll just put an entry in the table for when we are going to modify that. And then I think that's why it ended up being, kerning ended up kind of being by default defined as this thing that adjusts a default spacing, right? So that's how it goes. So yeah, so that's how much time we got left. All right, so we got about 20 minutes left. So 20 minutes left. We got 25 minutes left. So that's what a font file is, right? A font file, and a font in general, you might say, is something that declares all of these guys, right? It declares all these glyphs. It declares some fundamental things that we might have, like what are often called metrics of the font metrics. Which are basically saying, you know, like where's the baseline, descenders, ascenders, you know, some set of numbers that gives me a little bit of an idea about how the font is laid out. And then typically also a kerning table, which allows me to sort of know how I might want to adjust the spacing of these fonts to make them look the way the fontographer intended. Unfortunately, a lot of times these tables are awful. The fontographer does a really lousy job. And that annoys me to no end, but what are you going to do? And then finally, the thing that font files have oftentimes is they have something called hinting as well. We don't really probably care very much about hinting, but what hinting is if you're trying to make fonts that appear very, very tiny, then there are some things that you don't really want to do. So for example, if you're talking about a font that was going to become rasterized on a very, very small scale, so let's make a little grid here that we're going to rasterize, right? 0, 1, 2, 3, 4, 5, 6, 7. I'm going to make a little 8 by 8 guy here. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So, you know, if I was going to rasterize a font on here, one of the things that can easily happen is if you're dealing with a proportional font, again, it's resolution independent. It doesn't know what's going on. So we take something like that example I gave you where you have the T, and what we end up with is some really bad scenario where the T, the way the T lines up in our grid will look like this, okay? Well, okay, maybe not exactly like that. Try that. Okay. Now what you can see here is that our T is only 1 pixel thick. But because of the way that it happened to line up on the grid, it is now a ½ pixel thick in this row and a ½ pixel thick in this row. Now if we were to render that even with anti-alias rendering, what we would get is a very wide gray T, right? Because it's like halfway in all over the place, right? And that's not what you want for readability. What you want is this thing to snap to the actual pixels, and you wanted to draw the T like this because that would have been what was actually the most legible, right? Oops, I should not quite do that. I didn't mean to do that one. There we go. right? You want to draw the T like this, or did I mean to do that? 1, 2, 3, 1, 2, yes, okay, sorry. Like that. So yeah, that is what you would prefer to do. And so what hinting was a way of describing the fact that you wanted to do this to certain letters, like stems and stuff, to try and line them up with pixels so that you wouldn't get that kind of effect. It's not really relevant anymore on super high-res displays, so, you know, Retina display or whatever. Craziness. When the pixel count gets high enough, you're always dealing with enough pixels that it doesn't matter. But when you're talking about, you know, an 8x8 font or something like this, it starts to matter. So there you go. So that's typically what's found in a font file. And our job now is we want to build something that will allow us to take these font files, right, take fonts, and be able to use them in Handmade Hero. And we have a number of ways that we could do that, right? And so we kind of want to think about what are the ways that we could do that, what's going to be most efficient for us, and I'll kind of propose how I think we should probably tackle it because, again, Handmade Hero doesn't have a lot of need for fonts. It's not a font-centric game. So it should probably do something with fonts that's relatively easy and is fast to render, like isn't going to be some kind of concern for us where we're spending all of our time thinking about how our fonts are working, right? Okay. So option one is we could actually load, you know, TTF files or something, right? We could actually rasterize the fonts directly, okay? And what would that look like, right? Well, what that would look like is we'd have two options for that. One would be if we were in a relatively sane way of doing it, right? Is we would load in the font glyphs, right? So we've got that T. We would load in the font glyphs. We would turn these into triangles using a thing where this is typically a process called tessellation, which we haven't talked about because we don't really need to use it in our game at all. But we would turn these into triangles, right? And then we would actually have like an outline version of that font, right? That we could then use to render things. Now, of course, there's a problem. There's a caveat there, which is if we were to do that just once and just use the fonts in this format, we would have a problem when we went to do like our S's, which is that we'd have to pick some discretization of the S. Like we'd have to pick some degree of fidelity when we turned it into triangles. And then if we zoomed in too much on the S, we would be able to see that this part was a line and not a curve like it was supposed to be, right? So that's one thing we could do. But of course, we could always fix that by tessellating dynamically at runtime and saying, okay, maybe we write a really fast tessellator, and we then say, okay, how big did you want the S? We'll tessellate it more or less depending on how large it is, blah, 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 right? So we could load TTF and tessellate. That's one option. Two is we could load TTF and implicitly rasterize. Again, not something we really have covered too much on Handmade Hero, but we actually implemented it already. We actually did one. And when did we do that, right? Well, if you remember, when we did our triangle, our quad fill, remember how we did that? What we did is we said our quad was a series of edges, right? It was a series of directed edges. And what we said was a pixel, we like figured out a bounding box for our quad. And we said a pixel in here is going to be filled by the quad if it is included inside all the edges, right? That was what we said. You remember this, right? Well, we could go write the same kind of, that's called implicit rasterization. It's basically you have some function you can evaluate. Implicit, I've talked about implicit, explicit a little bit. Implicit is f of xy, some function that we put in xy and it tells us like, you know, some value out that's like, for example, whether it's included, right? Whereas explicit is like something where I feed in some parameter and I get out the xy of it. So like, if, you know, you could imagine like drawing a line, you feed in successive values of t and you get points along the line, right? So implicit rasterization is when we're talking about being able to step through pixels and say, is this in the shape or isn't it, right? And how do I fill it, right? So we could do that for our fonts. We could do that by saying we've got these Bezier curves, right? Whatever they are for our S. And we're actually going to do an implicit rasterizer that says for any point, we can ask the question, is it inside or outside of these curves? We could do that. You typically do that with what's called a line test, where you look to see how many times you have crossed over shapes that are in your set, right? And if you've only crossed over, going in one direction, if you've only crossed over one line, it means that you're inside, right? Whereas if you've crossed over two lines, you're outside, right? And it's odd versus even, right? Because you could do, if you did something here, it's like I could go in, out, right? So it's basically like if I've crossed over an odd number of times, I'm inside the shape. If I've crossed over an even number of times, I'm outside of it, right? We could write that. And the benefit of that is that just works at any resolution, right? No matter how you scale or shrink or warp or do whatever you want to the S, we would always have a perfectly smooth curve going around the S, right? So that's another one. But I don't really think we need any of these, right? These are overkill. These are drastically overkill. They're overkill for 99.999% of all games, right? Because most games just don't have that kind of an unpredictable, heavy reliance on font shapes. Most games know their target resolution or thereabouts, or a couple of them. Most games know how big the fonts will generally be appearing on screen. So most of the time, making a system that is capable of doing this much work with the fonts just simply isn't that important. And you're wasting your time if you go hog wild on it. It's time you could have spent doing some other feature in the game, right? And so typically you go with option 3, which is PreRasterized fonts, right? And the nice part about PreRasterized fonts is basically pre-rasterizing fonts turns fonts into something that your game can already handle, right? We already know we can blit bitmaps to the screen. We even know we can transform and scale them, right? We've done that with our hero sprites and the sprites for the background and all that other stuff, right? We've built good systems for doing that. And so the nice part about pre-rasterized fonts, right, is pre-rasterized fonts turns fonts into a problem that we already solved. And the way that that works is if you're trying to do pre-rasterized fonts, what we say is let's build bitmaps that capture the font at a certain resolution. We'll say, okay, for Handmade Hero, here's our target resolution, right? We want 1920 by 1080 or something, right? And we want our fonts to show up roughly this size. So, we want them to be, 40 pixels high. So let's just rasterize the font out at 40 pixels high. We'll save the results of that rasterization into a set of bitmaps or a single bitmap where they're like packed together, whatever, right? And then when we want to actually draw these, we will simply put them back on the screen, right? We will simply blit from the bitmap just like we blit from everything else. Very straightforward, right? Nothing crazy happening. Okay, so that's a lot easier and a lot more straightforward, and it also has the nice aspect of no matter how complex the thing is that pre-rasterizes the fonts, it doesn't matter because it's not happening at runtime, right? Here we would have had to start thinking like, oh, what's the performance considerations of this, and is it going to start impacting my frame rate if whatever, like, because there's complexity here. Here we know that it's just going through the standard bitmap blitting path, so I pretty much know exactly everything I need to know about it. And no matter how complicated the glyph is, it doesn't change. It's just however big it appears on screen is how much it costs. That's it, right? It's just like any other bitmap. There's no magic to it. And so we can rasterize any font we want that way, no matter how crazy it is, and that's fine. So how do we do this, right? How do we do pre-rasterized fonts? Well, typically what you do is you start with a bitmap, and you start packing glyphs into it. So you might say like, okay, I start and I put the letter A in here, right? And then I go to the next one and I put the letter B in here, right? And I end up with a bitmap that's got all my letters in it, right? Da 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 da, right? And I just pack all the fonts into a bitmap that's just, I know I can load that bitmap and draw my fonts, right? And in Handmade Hero, we don't really pack things into bitmaps much, so we could also just store these separately as separate assets in our asset file. If we wanted to, they could just be separate, right? Doesn't matter. However you want to do it, somehow we get all the actual character images and we rasterize them into actual bitmaps, right? Now, what do we store in the bitmap? Well, we don't really need any color information because the font probably will be colored on the fly when we actually, we'll probably want to be able to change the color of the font, so it'll just be white, right? So really, this is going to be a monochrome bitmap as well, right? It can just be an 8-bit value that tells me how much coverage there was, right? It can just be like an 8-bit value that's like the anti-aliased white version of this font, like grayscale, would probably be fine. Now, you could do color if you were doing some font that was fancier and had like, some kind of color, maybe your artist makes the font custom for you or something. That could be too. But most of the time fonts aren't color, so you can just store an 8-bit version that's basically just the anti-aliasing of the font. That's all it is. Okay, so you need that. You need some way of storing all the glyphs. You then need a bunch of tables, right? First of all, we need the code points, right? We need to know where, we need to basically have a mapping that says, all right, the letter A, right, whatever that is, right? So we need the letter A maps to like this location, right? So there's like a rectangle or a bitmap ID or something that says, where is the glyph for the letter A? How do I get the glyph for the letter A, right? I need that. Then I need some positioning information, right, for the letter A. Where does that go, right? Because remember, you might have a letter in here that's like lowercase a, right? It's much smaller than large a. And so I can't just use the size of the bitmap to tell me where the things go. I need to know, okay, you've shrunk it down to the minimal box that for storage space. How do I then position that relative to like the baseline, right? Like we were talking about the fonts. How do I position that, right? So we need some positioning information. And then finally, we need the kerning table, right? We need a way of knowing for any two characters, how far should I advance between them, okay? So we need to store a bunch of information with our font that can allow us to get all of that information back when we load the thing in, right? So what we're going to want to do tomorrow, since we're about out of time for today, we have a little bit more. I think we started about 10 minutes late, but this is a good point to wrap up anyway. So what we want to do tomorrow is start figuring out a way to pre-rasterize our fonts, like into our asset pack file, for example, in a way that includes all of this information and includes the font glyphs as well, right? And so that way, so we'll kind of expand. I think we did a pretty good job in our asset system, of sort of, for lack of a better term, making it extensible. So adding in another type of asset that was a font, if we had to, would not actually be very difficult, right? And so if we find that we would rather make a very specific way of handling that, we could do that. But the other thing that we could do, amusingly enough, is we could just make it so that the fonts, I think we probably could even do something where the fonts just use the tag matching system still to like get the code point out that way, which would be kind of amusing. But anyway, point being, that is basically it for fonts. And so that is the majority of what we have to do tomorrow, right? Is just we have to figure out how we are going to start building one of those font things such that we can start using it in the game. And it's a bunch of drudge work, really. It's not going to be particularly exciting. It's like what I've told you so far is basically what you need to know to do it. It's just I'm going to have to now show you sort of the annoying part of like interfacing with Windows to get your fonts, or some other scheme by which you could generate the fonts that you need. You could also use like the STB TrueType library, for example, to generate them. So I'll show you how to do it using Windows, and you could also symmetrically use some other operating system to extract the fonts out of it. But you could alternatively use OpenType or STB font. STB TrueType, which is one of Sean Barrett's libraries. It's a great little TrueType font system that really small amount of code that's easy to use. So that's another way you can do it too. So that's about it. I will go ahead and go to the Q&A now. So if anyone has questions about fonts they'd like to ask, now would be the time. TTBJM, aren't there licensing concerns with fonts? Well, it depends which method you are picking. So if you are doing one of these methods, you may, and it's kind of a legal gray area depending on exactly how you implement it. So honestly, I guess I don't really know, and I don't even know if anyone really knows. With these, you would probably have to license the font file, the font that you, like so with either of these methods, you would probably have to license the font to use like in your game, right? So if you wanted to use a particular font, you'd have to go get a license for that font, even if you didn't ship the TTF. So even if you don't ship the TTF, you would probably have to do it if you literally did one of these methods. There's actually other ways you could do it here that might actually not require that. The amusing thing with this method is you never need a license for this method. This method is always free. If you are in the US. If you are in Europe, that might not be true, because there are other places have different copyright laws. But the way that copyright works in the US is fonts cannot be copyrighted. So the only reason the other methods do require a license is because the other methods are technically software. It was ruled in a famous Supreme Court ruling or it might have been, I don't know if it was a Supreme Court ruling, I take that back. It might have been a district court ruling. I don't quite remember. But basically there was a ruling that said that because the TTF or a font file was basically instructions to a computer on how to generate the font at any resolution, that it was copyrightable as software. Now the font is still not copyrightable, which means if you were to load it up on the screen and trace it to make your own new outline version, that would be legal. And you could ship that version with no license. But if you actually used their TTF, even if you translated it into another one automatically, it would still presumably violate the copyright because you are translating the program directly at that point, not the resulting font shape, which is not copyrightable. On the other hand, if you are to rasterize the fonts, you are only left with the bitmap, the actual image of the font. And at that point, as far as anyone knows, there is no way to sue you for copyright infringement because fonts can't be copyright. It is not a computer program, it's just an image, and the image of a font is not copyrightable. So, in the US, no, I do not believe there are any licensing issues with that. If you wanted to be safe rather than sorry, you could always license fonts, they're not super expensive. But no, this method you don't. If you want to dynamically create the fonts on the fly, on the other hand, you absolutely do need to license it, even if you are in the US, because that is copyrighted. Will you support Unicode in Handmade Hero? Yeah, I think we probably will. Could we not pre-rasterize our fonts whenever the resolution is changed at runtime, basically? You could, but I typically don't like to do that because if you do that, then you are basically shipping an extra set of complexity in the game, right? Like, I don't really want to ship a font rasterizer in the game if I don't have to, right? Because it's just one more thing that could go wrong. And so I like to just treat them as regular art assets if I can. If I can't, then I can't. Will you be writing something using the font before you code the actual font reading, etc.? Well, yes and no. To generate the font files, no, we won't, because we just need to get the data in there. But to just determine the font API, yes, we'll write some stuff that's like, how do we want to actually try to print things, and then we'll make that work. Will classic bitmap fonts remain relevant in the coming years, or will we just start flat out with vector fonts forevermore? I don't really feel like bitmap fonts are super relevant except in retro. I feel like vector fonts are pretty much the thing, and it's just, you tend to rasterize them down to bitmaps, but I don't think you hand author. I don't think the idea of hand authoring a bitmap font is really all that relevant except for retro style looks. But there will be retro style looking games for a long time, I would imagine, right? Possibly forever. So that it won't go away entirely, but yeah, it's not really that relevant most of the time. Are you doing quantum mechanics? No, because I don't know any quantum mechanics. Did you ever try making a font yourself? Yeah, I actually did make a font myself when I was little. It was a bitmap font though. It was not an outline font. Will you have unique fonts made for the game? Possibly. I'm not sure. It depends if Yangshin is interested in that. She might be. If you have multiple font families and we're pre-rasterizing them, can you stuff them into one file? Well, I mean, in our asset system, yes. In other asset systems, who knows? It depends on whether the asset system supports it, right? Can I come live with you and you tutor me? No, we do not have a spare bedroom. How are combining Unicode characters that some languages have handled? Oh, so that's not something we super need to probably worry about in Handmade Hero, but yeah, so I don't think I've ever actually implemented this. In fact, I know that I have not. But in the Unicode spec, right, there's two kind of ways of talking about fonts. I mean, talking about glyphs, right? One way is to say I have Unicode code point, 87 or something, whatever it is, right? I guess 80 or something, right? And it maps to the letter P or something, right? And so when you see that, you kind of just know, like, I'm outputting P. And that's like what we'll be dealing with on Handmade Hero. But I know there's other things in Unicode which were the combining glyphs. And that's when the glyphs don't actually form separate pieces, right? So instead of just thinking about like, oh, it's a P and then it's an I and then it's an L and an L, right? Instead of thinking about that, it's actually more like, imagine with an I shape, you were to have the I broken into two pieces, the lower part and the upper part, right? And this one was one code point and this one was another. And when the engine sees this one followed by this one, it's supposed to know that this one, is placed up on top of there or whatever, right? I have never even looked at that part of the spec. I have no idea what it demands of you. Meaning, I don't know like if you actually have to do anything special or if you can just roll it into the kerning table or what, right? Because it's a combination-based thing. So it's possible that like you could do something fancy there, or it's possible that no, you really have to look at it and go, okay, it's this code, and when I see this code, I know I have to check the next code to see if that code is this, because if it is, it means something different. It could be way more complicated, right? So I've never looked at that encoding, and I have no idea how that stuff works, right? Naysayer 88. I became a much happier person once I started rasterizing fonts on the fly all the time. All the time? So you mean you actually just rasterize the fonts like literally right when you're about to draw a given glyph, you rasterize it at that time? Or do you just mean, well, I guess I'm not sure what you mean. A bit off topic, what makes code publishable? You said you wouldn't publish the current Win32 platform layer. Exactly, why not? I don't usually use the term publish because I don't know what that means exactly, but ship is what I would have probably said. Maybe I did say publish, though. What I mean by that is the Win32 layer right now is just not, like, it doesn't support all of the code paths that you would actually need for a robust experience on Win32, right? It doesn't go through the 3D hardware layer, which means that the frame rate won't be right. It doesn't have VSync because it doesn't go through that as well, which is bad. It doesn't, probably handle like app activate correctly, like when it's in the background. So there's like a bunch of things you want to do to your Win32 platform layer to make it like shippable quality. And so when we go, to final the game, we'll go back to the Win32 platform layer and go, what are all the things we want to do to make this more robust, right? That would also include like testing it, right, on a bunch of people's machines, so that we could have a better idea that it was actually, more usable. Will you be writing your own pre-rasterizer from scratch or using a third-party tool? We will actually be able to do this entirely with Windows, so that's pretty easy. In which episode will you implement Unicode skin tone emoji modifiers? Well, obviously, that's the most important thing to do. I mean, if we don't have the ability to have every possible skin color in our emoji, then can we really call it a unified world? And the answer is obviously no. And so, in order to preach the proper amount of sort of unified world global happiness, we should obviously have all the skin tones, including ones that don't even exist yet. How much time do you spend preparing for each stream? None. If you were to have a loot history or storyline history, you mentioned 40 pixels. If you wanted to allow users to adjust this UI, would you still do pre-rasterize? At what point would be the threshold for including a proper non-rasterized version? I think it's basically a judgment call. Like, if you want to do pre-rasterized fonts, you just have to have some idea that you can meaningfully cover the various usage scenarios that you want to cover with those pre-rasterized fonts, right? And so including a non-rasterized version is just a judgment call you make when you're like, in order to get the quality that we want and the variety of sizes that we want, we need to switch to, a rasterized version. Miblo, the Eulerian method you use for the particle systems moves stuff from high density to low density cells. Could the Eulerian method be used the other way, e.g. to make something that has gravity and pulls low density stuff towards itself? Also, I wonder if Eulerian simulation could be used for AI systems, maybe having different characters being attracted to or repelled by crowds. So first I will say that the Eulerian method, the term Eulerian refers strictly to, like I was saying, that discretization on a fixed grid, on a regular grid. Whereas Lagrangian referred to discretization into free-floating points, right? And so the important thing to remember there, and we didn't go into it in detail because we were just kind of, like I said, that was a 2-day sort of excursion into that stuff. But the important thing to remember is that actually, if you want to go further down the simulation route, Eulerian is just about the discretization. What system of equations you choose to solve on that system can be any physical system, right? So we didn't get to that stage because we didn't spend 2 weeks doing Eulerian methods or whatever. But actually what you do is not the hack that I did on the stream where I just picked some arbitrary numbers and shoved them in there, right? What you actually do is write a set of physics equations that are designed to govern the system that you are trying to create. Then you actually discretize those equations onto the grid, and you write a solver that actually does a solving step on the grid, which we never got to. Because there's a bunch of stuff you can do that are hack Eulerian, like what I did, where you don't have to do all that stuff, and you can still get useful results. But the real method, the full method, is actually much more powerful. So it can do stuff like simulating gelatinous liquids that cohere together and have surface tension. You could do real fluid dynamics on an Eulerian grid just fine, right? And so can you do gravity? Absolutely. You can do anything you want. Just the degree to which it's appropriate and how fine the grid has to be to capture what you want. All that stuff is kind of like part of continuum dynamics. If you're interested in this, reading about this more, continuum dynamics is what that was, what I was talking about. You could, oh, is this a, oh, this is, Oh, it's Michael Cass. Yeah, skip that. I thought it was going to be Bera for somebody, and I'd say take a look. But you know, if you look at continuum dynamics methods, it's a gigantic field. I don't know if there's good. Would there be? There's probably a SIGGRAPH course notes like on it, which might be good. Maybe not. I don't know. Post a thing on the forums. I could try to find some good references. I think Pseudonym 73 might have already posted some good ones. But it's a whole field, and there's a ton of stuff in there. I mean, you could spend your whole life, and people doing nothing but that kind of simulation work. So it's very rich, and anything that you want to do, you can do. It's just a question of how much it costs to do it, right? Gasto5, isn't abuse of text in a game a bad game design idea? Well, I'm not a game designer, so I don't really... I can't really answer that, but what I would say is I suspect that, like everything else, the amount of text in a game design is dependent on whether that design is about text or not, right? If your game is not about reading things, then yeah, it's probably bad game design. But if your game is about reading things, well... Will you use correct typography terminology for the game, or will you be carefree about it? Probably carefree. Typography terminology, there's not really a huge reason to be super accurate about it. I don't know that you gain all that much from that. You know, you can always go read a typography. There's not that much terminology actually in there. Robbie, by adding more and more layers of complexity to the engine, do you start to measure and optimize those parts just when the FPS is low enough, or when do you usually start with optimization? Yeah, so there's two things. The optimization is really not the only one. It's definitely a big one in games, so that's true. But there's really two reasons for the debug view stuff. One is optimization, but the other one is bugs. It would be really easy to ship a game like Handmade Hero with lots of bugs in it that no one would ever know about. And you might say you don't care, but actually it leads to a worse play experience. And those are kinds of bugs that are like, oh, the AI decided to do something stupid because we had a bug in it, and then like that monster isn't as fun as it should have been, right? A lot of stuff like that you will never know because there's no way to design unit tests for it. There's no way to inspect the code and figure it out ahead of time. It's too complex. And so the way that you need to tackle those is by having visualization that allows you to see what the code is doing in an intuitive way on the screen all the time, so that you can always be aware of what's happening and notice when problems are occurring. And I would suspect that even right now, there are bugs in our code that we just don't know about, that when we implement more Viz stuff, we will just see. And we're like, there was an obvious bug. Like, we just saw it, right? And it won't be as many right now because, like I said, we haven't done sort of the things that are more temporal, like AI and stuff that work over time and sort of have that. But like in our threading, there's probably like a bug in our threading that when we visualize our threads, we'll just be like, oh yeah, right? So there's probably just bugs in there, and there's a lot of bugs that because games are things that happen over time, there's usually a lot of bugs that simply cannot be tested away. And that is why visualization is so important, because it's one of the ways of really improving the quality of the game. And so, it's almost visualization is almost less about optimization and almost more about robustness, really. What do you think is the hardest challenge for you in programming these days? Really, it's the poor quality stuff, honestly. Between how bad Windows has gotten and how bad Developer Studio has gotten, and the fact that Emacs is so slow, and it's just all the tools are garbage. That's the biggest challenge for me, because it's like, I don't know, I could go try to rewrite all those, and to some degree, I am starting to try and rewrite some major portions of what we use at Molly, but it's a bit of a struggle, and it's always every day it sucks nowadays because every day when you go in and you do programming, you always just feel like you're like so alone, right? Because you're like, you know that nobody who works on Visual Studio had any idea what they were doing. And like, you know that nobody who like shipped the versions Windows 10 had any idea what they were doing, right? You're like, they didn't care about me. They weren't trying to make my experience better. Like they were trying to figure out how to put ads in it or how to make it good for, you know, a Java programmer at IBM or whatever, right? And it's really frustrating. And so, you know, John Blow, I guess, who I don't know if he's still here on the stream, but he and I talked about this a long time ago. And I think I tapped out earlier than he did. I sent him a mail a long time ago where I was like, I think I got to start working on an operating system or something because I've had it. Like, I can't take it anymore. And he was like, I don't know if that's such a productive thing to do. You know, I mean, like, there's so many things we could do. You know, is that really a good idea? But about a year later, he tapped out too. And he was just like, yeah, probably, like, it's all gone to crap and we got to start doing something about it, right? And you'll notice he's actively doing something about it right now. Like, he's trying to make a new programming language because he's like, we got to fix this stuff. Like, it's obvious that nobody else is gonna, so like somebody who actually cares has to go do it, right? And personally, I think that's really awesome because, you know, it gives me a certain measure of hope every day to know that someone like John is working on a new language, because it means there's a chance that when I sit down to program in 5 years, it won't be about how awful C++ is and how nobody who works on that language has any idea how to program, which is how I feel nowadays, right? I know it sounds harsh, but that's how I feel. I literally feel like the tools I use all day were written by people who have no idea how to program. Like, they're so far behind the curve on like how to program. And it's like the operating system, the text editor, the compiler, the debugger, they all just feel awful, you know? And they didn't used to feel that way. They used to feel pretty cutting edge. When I used to program on the Amiga, I was in awe of how good the text editor was. And like, it was crazy to me that they were able to even do that stuff in like, you know, 256K, right? And nowadays, you can't even get a text editor to update in real time, you know, on a freaking Jeep, you know, dual SLI Titan or something, right? Forget it. Because it's just so slow, it doesn't even have to do with the graphics. They're running C# in the background or doing it right. And so that's a real challenge. Like, it really does make me miserable. Like, it really upsets me at like some core level. And so a lot of my hope for the future is just about like, maybe if enough of us are this miserable about it, someday it'll change. And to a large extent, that was a huge motivating factor behind Handmade Hero, was that I felt like if I just kind of did some programming that maybe was like, here's how I like to approach programming problems, and I would like more people to start thinking about programming down at a lower level and caring about like more holistically what the code is doing, that might inspire people to do projects that would start to, you know, change that culture, right? And turn it around to make it more like it used to be when the tools I used were good. And honestly, like, I've been really encouraged by what's happened, because there actually is more than one person right now who specifically after watching Handmade Hero went and started like a text editor or something, right? And like someone started a paint program recently too, right? And like, that's just so encouraging, because I feel like it's not that hard to actually replace some of these things. Yes, it's a year or two of work, but it's not 20 years of work. It just takes some people to actually care about the quality of the end product. That's all it really takes, right? And so in some sense, like, it really has been pretty awesome to see that start to happen, because if I can have any small effect on encouraging people to do that, it would make a non-trivial difference, even just selfishly in my life, to someday boot up an editor by someone and it's like, this editor actually works, right? Like, that will be so great. And so, you know, I feel like there's a chance it's going to turn around, and I didn't feel that way probably like a year ago. So in some sense, like, yeah. John Blow says, the worst part is you say stuff about these tools being terrible and nobody seems to understand they are terrible. Everyone is like, what do you mean? Yeah, and I mean, it's true, right? It's hard to articulate sometimes. It's hard to articulate it because if you haven't been there, if you haven't used a really fast text editor, then you don't know that yours is slow, right? It's like if you've only ever eaten, if you've only ever eaten the fillet of fish sandwich at McDonald's, right? It's pretty hard to tell someone that, like, no, really, like, sushi is pretty amazing. Like, there's some really great stuff out there, right? And that's just how it is. You can't. It's hard to convince people something's terrible until you put something in front of them that's 10 times better, and they're like, oh, right, well, there you go. It's like probably no one thought Windows CE phones were terrible until someone handed them an iPhone, and they swiped on it and were like, oh my God, it's magic, right? But that's just because, if you haven't experienced, you don't know. I mean, right now, the things I'm complaining about and the world I'm envisioning that could have them fixed is also very limited. Like, in 50 years in the future, maybe we'll all be living in some weird VR reality where, like, we just think thoughts and the code materializes, right? So I even don't really know how bad the tools that I would think are good actually are bad compared to, right? So, I mean, I think that's why we have to start building some good tools to show people, like, hey, by the way, Visual Studio is a piece of junk. Like, here's actually what it would be like if your debugger was good. Have you considered signed distance fields for text rendering? You can't render text with signed distance fields unless you use, you actually need a more complicated encoding. So the reason is because signed distance fields are always rounded, right? And so you can't do things like hard edges. So in order to use signed distance fields for text rendering, unless you all want all of your fonts to look like blobs, you have to be multiple signed distance fields per region of your font. So you need basically like a hybrid encoding that's like multiple distance fields per region, like a Voronoi region with distance fields, which is pretty expensive. It's pretty expensive. So it's not a great choice unless you really know that you need it, because it is very expensive, and you have to kind of weigh it against other options. Don't you think you're not being completely fair to the other crowd who are not going to lower level? For example, I love and care about lower level stuff, but to pay my bills, I have to be able to output an application within 1/10 of the time it would take me if I did everything at lower level. I have no choice but to rely on WPF and C#. Well, I don't really think it's a question of fairness is the problem. It's a question of quality. Like, basically what I'm saying is I am not satisfied with the quality of tools I have. Now, I don't really care why that was that way, right? Like if someone couldn't do it because they weren't given enough time to do it, that's a perfectly valid excuse, but it doesn't help me, right? Knowing that there was an excuse for why Visual Studio sucks doesn't make Visual Studio not suck, right? That's the problem. And so since I know it is possible to do a better Visual Studio, what we need is people to actually say, I'm going to dedicate the time to actually making the good version of this thing, right? And so I really don't think it's a question of being fair or unfair, right? People should do whatever they have to do to earn a living, I guess, right? I mean, as long as it's ethical, hopefully. So that's not really the thing. It's not like saying that, someone's a bad person. But it is saying that I'm not getting what I need from this industry, right? This industry is doing a poor job actually delivering what I need to work with, right? And so it doesn't really matter if it's fair or not. Something needs to be improved. And hopefully there are some people who could figure out how to make a business out of that and start shipping development tools that actually were good. It's not enough to see a good tool once to understand that modern tools are bad. I feel like you also need to be a pretty good programmer, which is far from where most of us are now. If you are a mediocre programmer, you won't feel it. Do you agree? I don't think so. I I think maybe for modest improvements to something like Visual Studio, maybe that's true. Like fixing how long it takes to step in Visual Studio to make it instant. Maybe other people wouldn't feel that as much because they don't know the value of being able to like quickly debug your code or something. I don't know. But like, let's say you had a debugger that actually visualized all your stuff for you really well, where you were just like, oh yeah, I set a breakpoint there. Show me all the structures and completely, instantly diagrams them and points and like, here's where you are and here's where these pointers pointed to and right. Like imagine DDD written by someone who knew what they were doing. So like it actually like visualized it really cleanly, and as you stepped it like updated automatically and showed you all the stuff. And like, oh, you have vector 3, so it plotted them in 3D and you could spin it around. Like anybody, I don't care who they were or how novice they were, when they saw that, they'd be like, why am I using this complete piece of garbage? Like, why don't I use that thing? It'd be so much easier to debug my code, right? Anyone could see that. So I think if we actually built tools that did what we are capable of making them do today, right? If somebody spent the same amount of time making a good debugger as Google spends trying to target their ads, it would be so breathtakingly further along, right, than what we have today with something like Visual Studio, that I don't think anybody would not immediately see the difference instantly, right? But that's just not where we focus our time, right? Would you take a job in the mafia if they gave you a perfect version of Emacs in Visual Studio? Well, I am Italian. Which mafia were you referring to? If you're talking about Sicilian, they do accept non-Sicilians, I suppose, to a certain extent. All right, I think we have ended the stream. So I am going to close it down. Here we go. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you wanted to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so if you want to play around with it and you kind of learn by doing, which is a very good way to do it, you can go ahead and do that on this website. We also have a Patreon page if you want to support the video series. We also have a forum site if you want to ask questions or view an annotated episode guide or see ports to Mac and Linux that the community have done. And finally, we have a tweet bot that tweets the schedule, so if you're trying to catch us live, that's the place to go. It will tell you when we will be live. That's about it for today. Tomorrow is an unusual time. It is going to be at 8 o'clock, which and actually also I believe Jonathan Blow will be streaming a language development update earlier in the day, so 6:30 I think is the time for that. So you'll want to check out Naysayer 88 at 6:30 for sure, and then after that, Handmade Hero will be streaming at 8. So it is a night packed with programming streaming for your viewing enjoyment, ladies and gentlemen. So hope to see you back here tomorrow for that, 8 p.m. Pacific Daylight Time, right here on Twitch. So until then, have fun coding, and yeah, I'll see you guys on the internet. Take it easy, everyone.